to go ahead and get started. I'm going to hang out mostly right here in front of the computer. I will walk in a little bit today. Since I'm wearing this mask, I think you'll be able to hear better. So we're talking about the polygon angle sum theorem, the sum of the angles in a polygon. So it would be helpful probably to remind you that a polygon is a closed plane figure with at least 3 straight sides. Closed plane figure means all the sides meet. There are no sides open, right? A plane figure just means it lies in a plane. So it's a 2D figure, and it has to have at least 3 straight sides. So a triangle, square, rectangle, pentagon, octagon. Anything with straight sides is a pentagon. Straight closed sides. So you guys through with this? We can move on. Kayla, will you take your earbud out, buddy? Your thing. All right. So the diagonal. A diagonal is a segment that connects non-consecutive vertices in a polygon. So what does that mean? Well, this dotted line, AC, or this dotted segment rather, AC, that's a diagonal. It's from one vertices to a non-consecutive. So angle D would be consecutive. It's right next to A. Angle B would be a consecutive. It's right next to angle A. Angle C is the only non-consecutive vertices or angle from angle A. And then same thing here. If we draw all possible diagonals from one vertex of a convex polygon, it divides the polygon into 2 triangles. This is a concave polygon. We're not really too concerned with concave polygons, but I thought since they used that in the definition, it might be interesting to see. That's a convex pentagon, and this is a concave polygon. Normally we're talking about convex polygons. Still a 5-sided figure, still technically a pentagon, but that's not what I think of when I think of a pentagon. Is that what you guys think of? This one's the one. It might be shorter, fatter, taller, skinnier, whatever, but we don't usually think of those sides coming in like that. Think about it concave, it caves in kind of. Alright, the sum of the interior angles of a triangle always equals 180. I feel like we've pretty much hammered that home the first 9 weeks. So that should come as no surprise. So if we're looking at these different polygons, 3-sided polygon, 4-sided polygon, triangle, rectangle, pentagon. This is a 6-sided polygon. We call that one A. Does anybody know what a 6-sided polygon is called? It's kind of appropriate for Halloween. Hexagon. Get it? Hex, the witch spell. No? Nobody? Okay. Hexagon. So the interior angle sum of a triangle, that's the number of triangles 1. It has 3 sides or 3 angles, however you want to think about it. So 3 angles or side, 1 triangle, 180 degrees. So I'm going to put 3 angles, which is the same number of sides. 1 triangle, 180 degrees. There's 4 angles or 4 sides. That diagonal creates 2 triangles. And the total number of degrees would be 2 times 180, which is 360. So here, hopefully we're seeing a bit of a pattern. There's 5 sides or 5 angles. That's going to create 3 triangles with the diagonals from 1 vertices. 5 angles. 3 triangles. So 3 triangles, 3 times 180 is 540. And last but not least, 6 sides are 6 angles, 4 triangles, 1, 2, 3, 4, 720 total interior angles of this polygon. So there's a pattern there. The number of triangles plus what gives me the number of sides or angles? Plus 2, right? 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. Maybe it's helpful. Let's go ahead and put the sides here as well. So we're really going to be talking about the number of sides more than the number of angles. We're always going to use, for now, n is always going to be the number of sides. You need to remember what n stands for, because they're going to have multiple formulas where they use n, and n does not mean just anything. It means the number of sides. So you got to know that for these formulas and things we're working with now, we're going to use the variable n for the number of sides. So n, or the number of sides, equals the number of triangles plus 2. So the number of triangles plus 2 gives us 3. The number of triangles plus 2 gives us 4. And then we can rearrange that a little bit. The number of triangles minus 2, the number of triangles is equal to the number of sides minus 2. So 3 minus 1 gives us, 3 minus 2 gives us 1 triangle. 4 minus 2 gives us 2 triangles. When we know how many triangles there are in a polygon, that's how we can figure out the number of degrees in the polygon, some of the interior angles. John Luke, you're writing what we're writing, buddy. So the number of triangles equals n minus 2. Any questions? All right. So what is the sum of the interior angles of a nonagon? Well, first off, a nonagon has 9 sides. You are going to want to learn some of the common polygons. Nonagon's not so common, but for us, we will use nonagon off and on. So you can learn nonagon. We should know pentagon is 5, hexagon is 6, octagon is 8, decagon is 10. You should also know, if you look at your worksheet, look at number 5. It says 18gon, number 5 on your worksheet, not your notes, number 5 on your worksheet. You see number 5, I think says 18gon. That just means a polygon with 18 sides. It doesn't have a special name, you just say 18gon. If it says 20gon, that means it's a polygon with 20 sides. Make sense? Okay. So what is the sum of the interior angles of a 9-sided polygon? Well, we just, we learned how to figure out this in the previous page. So let's look. If we have 9, the number of triangles we can figure out here. Once we know the number of triangles, we multiply by 180, right? So here, the sum of the interior angles of a nonagon, first we're going to find out how many triangles there are. So n minus 2 gives us the number of triangles. So 9 minus 2 tells us there are 7 triangles. Does that make sense to everyone? Any questions about that? Jaden?
You said 9 minus 2 equals...
That tells us there are 7 triangles in a nonagon.
Oh,
So
I can't read what you wrote on the top part. 9 minus 2 is something triangle.
a number of triangles. So instead of n, we put in the number of sides. So now they know there are 7 triangles. Once we know there are 7 triangles in a nonagon, now we know that there are 7 times 180 degrees. that's how we know how many degrees there are in the sum of the interior angles of this nonagon, 1,260 degrees. A convex polygon has an interior angle sum of 1620. How many sides does it have? Well, how do you think we can figure out how many sides it has? We know that n minus 2 equals the number of triangles, we said. How many polygons do we choose? How many sides does it have? So the number of sides is the number of triangles plus 2, right? Number of triangles plus 2. So we can figure out how many triangles there are by taking this total of 1620 and dividing it by 180. I'm going to erase what I had there. If we want to know how many triangles there are, we take the total sum of the interior angles, 1620 divided by 180. Anybody help me with how many? Is that 9? I think that's 9 triangles. But we want to know how many sides there are.
11.
Very good, 11, because we learned that the number of sides is the number of triangles plus 2. So there, 9 plus 2 gives us 11 sides. Any questions so far? What's that? Which one? So you just 18, 19, and 20, there's 3 extra blanks in each of those, Matt. Just to help you organize yourself, you only have to use one of the 3 blanks on each one. Does that make sense? You can just use it to organize yourself. But the answer is the sides. Let's put this order, the sides in order. Alright, so the next thing we need to make sure we're talking about is what is a regular polygon, because some of the things we learned about only apply to regular polygons. A regular polygon is a polygon that is equiangular and equilateral. That just means all of the angles are the same and all the side lengths are the same. All of the angles have the same measure and all the side lengths have the same measure. Another reminder what n stands for, the number of sides. And I don't think yours has this, but I like that it's more specific. So yours just has the sum, but really what we're talking about is the sum of the interior angles. So the sum of the interior angles equals the number of triangles, or n minus 2, times 180. That's what we did up here, right? The number of triangles times 180 gave us the sum of the interior angles. N minus 2 gave us the number of triangles. Number of triangles times 180 gave us the sum of the interior angles. And I very often will abbreviate this because that's a lot. So sum of the interior angles. If we want to know the measure of one angle, that's the measure of one interior angle, and you don't have this labeled in yours, so I want you to write this part. I want you to write this part. You do not have that on your notes. Is everybody hearing me? Yours should say sum of interior angles. Yours should say measure of one angle. And I will abbreviate this one as MOA, as in the extinct bird. There is no MOA.
Wait, what is a mole?
What's that?
What does a mole bird look like?
I don't know, I think it was a humongous ostrich dinosaur looking bird. It's like the dinosaur ages. Alright, so these are some formulas. The number of triangles times 180 gives us the total sum of all the inside angles of a triangle. If we want to know the measure of one angle, we need to know the number of sides, and we can plug it into this formula. The number of triangles times 180 divided by the number of sides. if we want to know the number of sides and we know the measure of an angle, we can plug that in here. And that's what we're going to do for example 3. A regular polygon, equilateral and equiangular, has an interior angle, it's a MOA, of 135 degrees. Measure of one angle, that's what we're talking about here, is 135. How many sides does it have? If we know how many sides we have, we can find the MOA. If we have the MOA, we can find the number of sides. So we're going to plug into that formula. The 135 goes here. So 135, the measure of one of the interior angle, equals n minus 2 times 180 divided by n, where n is the number of sides. So now we're just going to solve for n. I'm going to multiply both sides by n to cancel those out. That's 135 times n equals n minus 2 times 180. And I'm going to distribute. I'm going to get my variables on the same side by subtracting 135n from both sides. Now I'm going to move my 360. I need to get isolate my n. I'm going to add 360 to both sides. Now last step to isolate n, divide both sides by 45, and n equals 8. So there are 8 sides. N equals 8, and you need to know that n represents the number of sides. Any questions? All right. Okay. Yep. Ethan, you keeping up? You ready, John Luke? All right, I can come back at the end if you don't finish it. All right. So find the missing angle measures. Well, we know this angle measure and this one and this one. Our variable represents our unknown. Anybody have an idea? Well, if we knew the sum of the interior angles of this polygon, then we could write an equation, right? So we need to know what the sum of these are. We need to know what this plus this plus this plus this equals what. Well, we can find the sum of our interior angles at that formula we just wrote. And it's n minus 2 times 180 divided by n, right? And in this case, this has n equals 1, 2, 3, 4, because n is the number of sides. So now we know that n is 4. So we counted the sides, so it's 4 sides. So now we just plug into this formula. So it's 4 minus 2. Oh wait, this is the wrong formula, my bad. This is why I use an eraser. I got ahead of myself. I used the wrong one, right? I used the measure of one angle. Just erase the divided by n. So This is another reason why I want you guys to have your notes out on your desk. We do need to try to remember, probably use flashcards for these. I review these once a year when I teach it once a year too, so I need to review them too. And so the sum of the interior angles is 360. So this plus this plus this plus this equals 360. So now we can write that equation. And solve. So if you add the constants, I think they equal 223. Subtract 223 from both sides. And x is 137 degrees. Any questions? Make sure you keep your head up. Sit all the way up off your desk, please. All the way up. Thank you. All right. Find the missing angle measures. So same thing here. I mean, this doesn't look like the same problem, but in essence, it is very similar. We want to find the missing angle measure. In this case, though, we got to find what x is first. We're going to find x basically the same way we found x here. But then once we find x, we have to plug into each one of these expressions that represents the angle measures. So first we're going to use our sum of the interior angles, which remember is n minus 2 times 180. First, what is our n? What is our n in this example, example 5? Kamara? 6. 1, 2, 3, 4, 5, 6 sides. So that's the formula. We're going to plug in 6 because our n, so let's write our n is 6 here. That's the number of sides. So now we know that the sum of the interior angles is 720 degrees. So we have to add all the angles and set them equal to 720. Ethan, you writing what I have up here? Just going to go through and combine like terms. And that's 18x. Go through and combine the constants. Negative 10 plus positive 10, well, that's 0. Negative 20 plus positive 20, also 0. So all we have is 18x equals 720. So divide both sides by 18, and x is 40. Does anybody have any questions about how we got there? So now that we know what x is, how can we find out what this angle is? How can we find out what the measure of this angle is, Brandon? Zyla? Multiply 4 by 40, right? Yes, multiply 4 by 40. So I'm going to go ahead because now we've got to find the missing of angle measures, and we don't have any of the angle measures, so we need 6 angle measures. So I'm going to put down here, I'm going to put the measure of angle 1 and 2 are both 4 times 40 because they have the same expression for their angle measures. So they measure 160 degrees. I'm going to call this one angle 3. The measure of angle 3 is 2 times 40 plus 20, 80 plus 20 is 100 degrees. Make sense? So wherever there's an x, we're plugging in 40. I'm going to call this one angle 4 just so I can identify my answer. The measure of angle 4. 2 times 40. 40 goes here. Plus 10. So we know the measure of angle 4 is 90 degrees. I'm going to call that one 5. Same thing. 3 times 40 minus 20. 120 minus 20 is 100 degrees. And the last one, 3 times 40 minus 10 is 110 degrees. Any questions? Ethan, you caught up with me? I'm getting ready to move on. I'll have to come back. Any questions on this page? All right, if you're still writing, we'll come back to it at the end. Now we're going to be talking about the exterior angles and how they relate to interior angles. We're looking at regular polygons in that these are equiangular. Well, actually, we're looking at equiangular polygons. You'll notice this first description or this first diagram. It's got a triangle, and all of its sides have an extended side. It's forming an exterior angle here. We did learn about exterior angles and triangles our last unit, exterior angles and remote interior angles. These are the exterior angles in this diagram. These are the exterior angles formed by these extended sides. And the second one, the rectangle, the pentagons, not right this second. When we're done, you can. I think we'll have more than 10 minutes left, John Luke. We'll see how much time we have left. Exterior angle formed by extending a side. So exterior angles here. What do you notice about their exterior angle and the interior angle that's adjacent to it? Say it again. That's true, but I'm asking, how do the exterior angle and the interior angle, what relationship, Tyron? They make 180. They're supplementary, right? 120 and 60 is 180. 90 and 90 is 180. 72 and 108 is 180. Also, there's something special about exterior angles of these polygons. You'll notice in the triangle example, the exterior angles have a sum of 360. You'll notice with the rectangle, the sum of the exterior angles of this rectangle are also 360. And the pentagon was not as easy to do in my head, but 72 times 5 is also 360. So what you need to know is no matter how many sides, the sum of the exterior angles of a polygon is always 360. Did you write that down, Maya? You've already written this whole sentence down? have that sentence written down, Gad? Alright, let's move on to the next example. An exterior angle sum of any convex polygon is 360. We just proved that, or showed that. If the sum is always 360, then to find one exterior angle in a regular polygon, you would divide 360 by the number of sides. So we're going to put that here. So an exterior angle equals 360 by the number of sides. Remember, n represents the number of sides. So if we want to find the measure of an exterior angle of a regular octagon, how many sides does an octagon have? It's a stop sign, right? An octagon has 8 sides. So the exterior angle of a regular octagon, that means an equiangular, equilateral octagon, same side length, same angle measures, is always 45 degrees. How many sides does a pentagon have? 5. And so, if we want to find the exterior angle of a regular pentagon, we take 360 and divide it by the number of sides. Something else that's helpful to remember, an interior angle is always equal to 180 minus the exterior angle because those are supplementary. Um, 360 divided by the number of sides equals the exterior angle. But 360 divided by the exterior angle equals what? The number of sides. So you can use this formula, 360 divided by the exterior angle equals the number of sides. So if you divide it by the exterior angle, you get the number of sides. If you divide it by the number of sides, you get the exterior angle. Does that make sense to everyone? So that's another little shortcut. Did you write this one, Gad? All right. Anybody have any questions so far? We're down to one last example. So the measure of an exterior angle of a regular polygon is given. So this is an exterior angle. Find the measure of the interior angle, then find the number of sides. So how can I find the measure of the interior angle? We just learned that, right? The interior angle equals 180 minus the exterior angle. That is the interior angle. If we want to find the number of sides, so the number of sides equals 360 divided by the exterior angle. And that equals 15. So n is 15, that means there are 15 sides. Any questions? You have some time, you can start your homework. We still have 14 minutes, so make sure you're not packing up. You can scan and submit your notes now if you like.